we have an alkene here, right? And anti-mark we said is going to add to the side that's less substituted. So will it be here or here? The BR adds.
The one
Here.
right? Yeah.
Yeah. So just add BR. And then for this,
How do we know it's anti-mark or something like that?
it'll be on the table. Yeah. You don't have to memorize it.
Oh, it's gonna be on the table?
Yeah. And then for this one, OH minus was one of the examples I gave for a small base, right? Small base.
So it's gonna be E2.
Is he also going to provide us that table? We got to memorize the small bases.
No, that one I would memorize.
Okay.
So it have two, it has
So
two, do what?
This is primary, secondary, or tertiary.
Primary.
Primary.
And then in the table, it was primary with small base. So it is SN2, right?
How do you remember like which one's SM2? You just remember, or is there like a?
That's why I drew out that table,
Meaning,
and then I just memorized that.
You just memorize?
Yeah.
is that table going to be provided or not?
No. I found that on organic chemistry tutors, like one of his videos.
Do you recommend this video?
That one was helpful. But for SN2, we know it'll just replace this, right? The leaving group with OH.
Okay.
And then
Wait.
for H2O. So whenever you see an alcohol, so OH, with H2SO4 in heat, that'll be E1.
How do you know?
It's always going to be this case. And the steps for this actually is we are going to protonate this OH. Because OH is not a good leaving group, so we want to make it water first. So it'll get a hydrogen from there and then be a good leaving group. It'll leave. This.
What's a leaving group?
Something that leaves the compound. So
BR is
So BR would be the one, the leaving group?
yeah, but also no, OH2 is the leading group here. This is gonna be it, right?
Yeah.
Oh, okay, and the third step. Yeah, okay.
But this is a primary carbocation, right?
Because it's attached to.
What?
It's attached to one carbon.
Yeah.
Yeah.
And you know, for E1 and SN1, we always look for rearrangement, right? So,
Sure,
I didn't know that. Yeah.
sure. Whatever you say.
So are you gonna take a hydrogen and put it to the plus region?
yeah, so this carbon has a hydrogen, right? The one right next to it.
Yeah.
And that can move there. And then it'll turn from primary to secondary.
And you always want, sorry.
No, my main question is just recognizing the E1 versus E2. That's
For
what it is.
E1, it's always going to be this.
Okay, how about for SN2?
For SN2, it'll be a couple things.
E1
like-
will always be H2SO4,
Yeah, this is the only instance I've seen for E1.
and tertiary would be that CO thing that he gave us, right?
Tertiary?
Like the big boy, the bulky boy.
Oh, for bulky base, it'll always be E2 Hoffman.
Right, is that the same thing we're talking about here, or is it completely
There's no
different?
bulky base in this one. So this one's a small base, right?
Okay,
And a small base with primary is going to be SN2.
what does that mean?
So the substrate is primary, and it's reacting with a small base, and it'll just replace the substrate with the nucleophile, OH.
And you said to memorize the small bases.
Yeah, I've only seen OH minus and CH3O minus. Go back to here. So we turn this from primary to secondary. And then E1 is always going to be Zaitsev, right? So the alkene can either add here or here. But Zaitsev is more substituted, right? So is it going to add here or here? There. So you'll have this.
Where'd you get that extra bond?
Where?
From second grade to what you just wrote. Where'd you get that extra
This
bond?
one?
Yeah.
So we're forming a alkene because it's elimination, right? But we also know that elimination 1 is always going to be Zaitsev. And it can either add here or here. So we choose this because this alkene is
What is this process about? I cannot understand it. What are we doing? Stabilizing the molecule?
yeah.
Oh, okay. All right.
Yeah, and carbon, it will rebond with the next carbon next to it if it loses a bond. Like if it's losing that hydrogen, carbon is going to want to rebond with a carbon next to it.
Right. It wants to
fill in that empty space.
Okay. It wants to reset itself into like the octet-role, right? Technically, that one right there would still have another hydrogen.
What's the end result here?
Yeah.
This
Maybe
is
that's
the
my
end.
question.
Yeah.
This is the okay.
Yeah, that's your
How does that alkene form?
Since it's okay. So we were taking
I don't know where the alkene is coming from.
so for E1 it was
She
it was
rearranged.
attacking
She took the
beta
hydrogen.
hydrogen, right? So removing a beta hydrogen can either be here
Oh, you removed it
or
from
here. Yeah.
Okay, that makes sense.
And we chose this one because
Wait, what makes
it's
sense?
Zaitsev.
Which one?
They removed the hydrogen to create that alkene. Like they removed the hydrogen from the core, from the site. Like you know the 3 carbon?
Yeah.
In that complex, there was a hydrogen, but they removed it so that they could form an alkene that's the most stable. Because alkenes are the most stable when they're connected to most substrates, right?
Right.
Yeah. But I mean, we could have removed a hydrogen from the other end, but like it wouldn't be stable, right?
The reason we chose here instead of here is because it's E1.
Oh, okay.
Yeah, E1 is always going to be Zaitsev.
Oh, okay, never mind. So that's the reason, not the stable.
Okay. So I'll do the next one.
Oh yeah, the Z ones are always, they have alkenes that are most stable, right?
Yeah, more substituted.
More substituted, sorry. Wait, sorry.